Before we get into today's video, I'd like to announce that I have a new website. My music production portfolio lives there. I have a blog where I'll be posting bonus content relating to these tutorials, but more importantly, I'm offering music production and education services. If you're an artist or a band looking for a music producer, you can contact me through the website and we can arrange to make your next project happen. I'm also offering piano and music production lessons. These can be conducted over video chat if you aren't local. All right, let's get to the video. Today, I'm bringing you a concept which I've never seen in my years of watching music production tutorials on YouTube. This started out as a shower thought that lived in the back of my brain for many months. I haven't used it in any of my songs yet, but I thought I'd try it out as a proof of concept, and I actually discovered some really interesting things in the process. Today, we're going to be exploring advanced composite chains, advanced composite feedback loops in composite chains. Thank you very much. Advanced composite feedback loop chains. This text will not render because it's off the screen. Bottom text. Before making this video, I quickly searched YouTube to see if anybody else had beat me to the mark, and sure enough, the basic concept of this had been done before. That's why I decided to amp up the complexity and take this to the next level. If you embody these lessons today, you may just create sounds that have never been heard before. Okay, let's lay some groundwork. Suppose we have a signal chain. This is your audio source and this is the output. Feedback is a term used to describe the process of taking a signal from one point in the chain and passing it back to an earlier point in the chain, creating a loop. This is what's called a feedback loop. Often effects are applied at this point before it's fed back, such as altering the gain or the volume of the signal before it goes back, holding it in a bit of a buffer and delaying before it's sent back, and also filtering it. Now, the most common use of feedback, I would say, is a delay or echo unit. They utilize all three of these things, just rebranded as this being the feedback knob, this being the time division, which is often either synced to the project, let's say it's a quarter note delay, or it could be in milliseconds, and the filter is usually a high pass or a low pass. Other examples of plugins which use feedback would be phasers and flanges, choruses, and even some distortion or saturation plugins. When these guys use feedback, they're operating at a very small or zero time loop. If the signal is being fed back into the chain louder than it was to begin with, i.e. the feedback would be over 100%, in an instantaneous loop it would basically immediately distort, and so a lot of these plugins don't allow you to do that. They max out at 99%. That being said, if you push the feedback all the way up or near that really high range, the frequencies which have been boosted by these effects will be accentuated because they're basically being boosted over and over again, and this is what really increases the amount of that effect. For instance, if you have a phaser and that's boosting a set amount of frequencies, then each of those frequencies only becomes more accentuated and you get a much more intense phaser that gets that really glassy, unnatural sound to it. Alternatively, if you were to turn up the frequency on a chorus effect, you would start to hear some of the effects that Flume used in his project called Hi, This Is Flume. It's very fun to play around with that and see if you can create some of the same effects that he did. So now we ask ourselves, how do we do this without the help of the feedback that's built into the plugins? Now, you should know that we're turning up the difficulty to hard here, which means we're in control of our own feedback levels, which means we always need to put a limiter after any kind of feedback that we're doing. If you don't know, a limiter is a plugin which has a ceiling, and any time the volume goes above that ceiling, it basically brings it back down, puts it in its place. So you can see here the ceiling is at negative 0.3, set that to negative 6, and let's get on with it. Now, there are a few ways to achieve a custom feedback loop in Ableton. The first way is probably the most visual and easiest to understand, and that's using sends. So I'm going to open up one of my sends here, delete whatever's in there, and I'm also going to copy paste my limiter onto this channel as well. Now, you might notice on the right here, there's two little grayed out boxes that say negative infinity, and these basically refer to the two sends themselves. If you try turning this up, you'll notice it's grayed out, but if you right click it, you can enable the send. All of a sudden, this knob here is your feedback knob. So I'll send this clap entirely to the send, and because there's no delay happening here, it's a zero delay feedback loop. It's basically instantaneously going and feeding back into itself. It will start to hear some of the resonant frequencies inherent to the sample. Dun. So I'm just editing this at the moment, and I realized that the tone that we can hear that I've been referring to as the resonant frequencies isn't actually related to the resonance of the sample or the input signal. It's more related to the sample rate of the project. Because I have my sample rate set to 44.8 kilohertz, that means that every time we reach another sample as the software is processing it, the feedback is going to be placed at that point. And because it's doubling up at that rate, that's the tone we're going to hear, not the resonant frequencies. I do keep referring to it as that throughout the rest of this tutorial, so just remember, I'm wrong, it's not resonant frequencies. So just to make this a little bit more interesting, I'll add an echo to our send here, and I'll set the feedback to 0%, so we only have one delayed echo, and I'll set the dry wet to 100%, meaning the original one won't be played through, but only that one echo will go through. So this will operate as our feedback knob here, and I'll set that to maybe -2 or something, and if we play it, we'll hear that we have a standard echo. Nothing too fancy here. Now suppose we have a second send, and on this I'll put a chorus. Set that to 100% dry wet, and let's enable the sends for all of these now. Now I can send some of this output to be fed back into itself, and I can send some of it to the other send. And so we'll have one version that's being echoed and one version that's chorus on top of the echo. Now, of course, as we can see here, the chorus has a built-in feedback function, but we can do that ourselves just by turning up the self-feedback of the chorus. I'll send some of the chorus signal to go back into the first one. So now we have bidirectional feedback. So now we're starting to hear that the tail is being fully extended because the feedback loop itself is enough to keep the sound sustaining. And this is what I would call a composite feedback chain. We have two chains of effects that are being fed into themselves and each other in ways that create loops, and that gives us really unique resonance and timbres that wouldn't be achievable otherwise. It looks like the chorus is actually still going. And that sound has been generated just from a clap source input. Okay, let's organize these concepts with some diagrams. I'm going to represent the input signal with the letter S, and I'm going to represent each of the feedback chains with the letters A, B, C. If I want to say that the signal is being sent to chain A, it will look something like this. A can be fed into B. This here is called a serial chain. Everything is applied in series. If I was to send S into A as well as into B at the same time, this would be a parallel chain. It's also worth noting that we can output the dry signal as well. These letters don't represent single effects, they represent chains of effects. Each chain might contain one or more effects, but the point of having them as chains is that we can hear what each one is doing, individual of the others. So in these diagrams, to represent a feedback loop, we just have to draw an arrow going from one letter to itself, and we can say that that is looping now. Let's say, for instance, we had a source that was going a little bit into A, and then A was being sent into B, B was being sent into A, and we also had self-feedback loops on A and B. This here would represent the feedback chain that I just made with these two sends. The final diagram I'm going to draw here is going to look something like this. We've got S going into A, S going into B, B going into A going into B, and then we'll have a third channel here called C, and A and B will both feed into that one. I'll come back to that later. I'm going to quickly talk about the shower thought that led me onto this initially. Ableton has many plugins with sidechain abilities. Sidechaining is usually accessed by this little triangle button here, and it can take audio from another point in the project and use that information to affect the plugin's behavior in different ways. Now, luckily, Ableton has this little monitor button here, meaning you can listen to the sidechain signal just so you can kind of test how it sounds, see what you're working with, and then ultimately turn it off so you're not monitoring it anymore. I got to thinking though, what if you just left it on the whole time? You would have an audio signal coming from another place, basically siphoning it in, and it would just be streaming that audio through this channel now. So I came here to try it out, and it turns out you can siphon audio all over the project, meaning you can take audio from a later point in the chain and bring it back to an earlier point in the chain as we just learnt before, exactly how a feedback loop occurs. This means you don't need to use the sends to create feedback chains, and you don't need to have them operate in this linear fashion. This was such a groundbreaking discovery for me. So for siphoning audio, I like to use the gate just because I think it has the lowest computational overhead. So let's put this onto our clap. Let's make sure we're putting everything before the limiter. And I'm just going to make a simple feedback loop here. So the way that we do it is we need to try and siphon audio from a later point in this channel. If we check the audio from, we can see we have the clap track here, but we can only take the pre-effect signal, which means before this. It wouldn't actually function as a feedback loop like this. We need to create an audio effect rack. Put that before the limiter, we create a chain, and then if we check here, we now have the audio effect rack. Anytime we're working with this, I like to put post effects. This means we can turn down the volume mixer of a chain without affecting how the feedback works. This gain knob will be functioning as our feedback knob, or the amount of volume that's being fed back into the loop. I forgot to turn on the monitoring here. So if we do that, we'll notice there's no audio going through. And that's because since the monitoring button isn't designed to be left on, it blocks all of the incoming audio. So to get around this, we need to make a bit of an alleyway around the plugin to allow the audio to come through. And we can do this by grouping it. So put it in an audio effect rack, open up the chains list and create a new chain. This chain will be the initial signal going through, and this will be for all the loops. Now, all of a sudden, it's allowed to get through. It'll reach this audio effect rack. The siphon will hear the audio going through the effect rack and replay it back through, and the cycle continues. I'm just going to copy over the echo from before so that we can have something a little bit more pleasing to listen to, and copy that into this audio effect rack here. This is basically going to house all of the effects that we want to be as part of the feedback chain. Okay, now we have our own internal feedback loop within a chain. Let's see how we can take this even further. Before we continue, you may be wondering why I created the exact same effect as I did with the sends, except putting them in an audio effect track and making it all hacky and siphoning audio around the place. The difference is all the sends in Ableton are in one place. You can't group them and you can't isolate them if you're just using them for a single effect or a single purpose. If you end up creating one of these really complex composite chains, you're going to be using a lot of sends for just one purpose, and they're going to be cluttering up your entire project. Personally, I think sends should be reserved for project-wide effects, such as reverbs or delays, those kinds of effects which tie everything together. If you're just using an effect for a single thing, it shouldn't belong at a project-wide level. It's a very common software engineering concept of having limited access. The only things that can access something are the things that are using it. I basically just don't want to be trying to remember while I'm mixing which sends are safe to use and which ones are reserved for these complex effects. They're very contingent on what the input source is. So if you feed in two or more things, they might mess up some sounds that you've created and spent time trying to balance out. You're basically just saving yourself a lot of headaches this way. If you're working on a pure sound design project where you're not actually working on a song, you're just trying to create specific sounds, go ahead. You can use the sends and that won't be an issue. Anything further in this tutorial, you should very easily be able to apply to the sends method. At the end of the day, it's up to your workflow preferences. All right, let's get back to this diagram that I drew earlier. So we have the source audio being sent into A and B. A and B are sending audio into each other, and then they're also outputting audio to the C chain. Let's look at how we can create this in Ableton. So what we created here was a basic self-feedback loop. When working with composite chains and things being fed into one another, you can do this either by grouping all of these in one big audio effect rack at the top of the channel, or a much more visual way, which I'm going to do just for the sake of this tutorial, is separate out all of the chains into their own audio channels. We can still siphon audio across audio channels, so this won't actually change the functionality at all. It just spreads out the workflow a little bit to make it a bit easier to understand. So I'm going to take this clap track and rename it source. I'm going to take each of these three and I'm going to rename them A, B, and C. I'm going to go and copy paste my limiter onto each of these right off the bat, just because I'll forget. Now for this thing, we don't have any self-feedback loops, so I'm just going to delete this from the source, keep the source clean, and we'll put all the effects on each of these chains. So we wanted S to be fed into A. Let's work on that first. We'll put a new gate onto A, put it before the limiter, open up this side chain, and we'll say audio from source, post effects. monitor. And if we look over here at the volume, you'll see that it, sure enough, has audio coming through. We can even solo it. If we had this set to post mixer, we wouldn't be able to hear anything. And that's why we always do post effects, because it doesn't take into account which tracks are muted, which tracks are soloed, and what this volume knob here is. It just looks before all of that. Okay, next up we have S going into B. Obviously the exact same thing as that, so I'm just going to copy over the gate, and we'll hear the clap going through B. Next up we have A going into B and B going into A. Now this is where this gets interesting, because both A and B already have an input, but now we're adding an extra input. And because these siphons don't allow audio to come in from the back, we're going to need to use the side alleyway method and have the inputs come through in parallel. I'm going to group the gate, open up the chain selectors, and right click the chain and duplicate it. So for the first one, I'm going to rename this source, and for the second chain, I'm going to rename it B. Audio from B, post effects, and so now A will be getting audio from B as well. Each of these will sound exactly the same. That's good. And we'll just do the same thing on B. Ah, you hear that? That is the feedback loop occurring. Now that we've added in these missing connections, A is being fed into B and B is being fed into A. This is the only internal loop within this composite effect chain, and this is why we hear the sound persisting after the sample finished. All right, let's finish off this chain by feeding A and B into C. Put a gate on C, side chain audio from A, post effects, group it, duplicate the chain, and this will be audio from B. So now C will just be the combined version of A and B. Don't forget to turn on the monitoring button. So you can break that loop just by turning down the gain of one of these A-B loop things. Okay, now to actually putting some of the effects on. On A, I'm going to add a delay. This is going to prevent that tonal instantaneous feedback loop happening. So we'll turn up the dry wet to 100%, feedback to 0, and now we got something like this. Much more similar to a regular delay. I'm going to turn down this gain knob a little bit more here so that the feedback is lower for the echo and we won't have as long of a tail. Now on B, I'm going to add a frequency shifter. I think it literally just shifts the frequencies in a linear fashion. And so compounding this effect means that if we're offsetting the frequency by a set amount each time, then each loop it will get lower and lower or higher and higher. So I'll just adjust the fine knob here and we can hear that effect happening. We can also play around with setting it to wide mode and just spreading it further and further out. And another thing I'm going to add is a saturator. At this point, I'm just going to turn down the output of everything, select them all and turn them down. For this saturator, I just want it to be pushed a little bit further into the saturator each time. I'm also going to chuck a chorus onto A so that each time it loops, it gets a little bit more chorusy. This can give some interesting results. EQ is also applied during the feedback loop because it accentuates each of the changes that you make every time it loops through. Small changes to the EQ will make a drastic change to the sound, especially with boosting. Finally, I'm just going to add a reverb to the output just to give it a little bit of space. I can leave the dry wet to 100% because even though this might look like C is the output, all of these are the output, really. We're getting some of the dry signal, we're getting some of A, B, and also C. So at this point, I'm happy with how the sound effect is sounding. I don't know where you'd use this. Maybe it could be a part of some interesting industrial track. But you can go through each of these channels and mix the output of them individually. So I'll turn them all down to start with and we'll see how we can make that work. So we'll start with A first. A and B are going to sound very similar. It's just that they'll be one step behind in the feedback loop. So we don't necessarily need to hear both A and B at the same time. We can just mix in one of them to get the same effect. C, however, that wasn't part of the feedback loop, so we'll need to mix that in to hear the reverb. So just playing with these, I've realized that the B delay happens before the A delay. That's because B doesn't have the delay and it's already getting that inputs directly from S. If this wasn't here, they would be exactly the same, but because this arrow is here and we're getting the dry signal from S, B happens first. So I'm just going to include that one and leave A out. Finally, we can mix in the dry signal. I don't think we want too much of it for this sound, just because as a sound effect, it's very abstract, and having a dry clap in the mix doesn't really emphasize the effect. I think it would make more sense to layer this with a different sound that kind of fit the bill a bit better. If we group all of them, then all of their audios will be sent to the group, so we can apply master effects to this without affecting the feedback loop or any of those things we've just changed. I'm thinking maybe a multi-band compressor, maybe some saturation to tie it all together. Maybe a compressor to just bring out some of that tail. Anyway, that's all for this effect. The results that I came up with were very different from the last time I tried it, to be honest. I think this is such a complex and versatile workflow to be using. I can really see so many different sound design opportunities opening up because of this. I've been telling my friends about this and they said, Josh, you're giving away your trade secrets, your secret sauce. But honestly, this isn't the secret sauce. The secret sauce is what you do with this. It's applying your own ideas, getting creative with the routing, writing it down. Honestly, drawing those little diagrams helps your brain understand the process so much easier, and you can just go crazy with this. I would recommend doing it in an isolated project to begin with, especially. You can always render these out. You know, I've got an audio channel here. I might just do that because it's a pretty dope sound. 1, 2, 3, 4. Amazing. Look at this. We got the techno rumble already. Anyway, if you like this type of more technical, kind of in-depth, complex video, let me know in the comments. Don't forget to subscribe, hit that like button, it all helps me out. If you check my website after this, I'll be posting a blog post relating to all of the information that I've put in here today. If you want to hear my newest album, it is up on Spotify and it's accessible via my website, but I'll put a link down below to all of that. Thank you so much for watching. I've been drinking coffee and I will be tomorrow. See you next Friday.